Welcome back. In the previous video, we finished the basics of net present value as a capital budgeting formula. In this video, let's start with a brain teaser. Our project has the following cash flow pattern. It costs $13.16 million today. It pays $7 million next year, and it pays another $8 million the year after. What is your holding rate of return? Easiest thing we did, right? First lesson.
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, turns out you cannot compute this with a rate of return. That is the fundamental formula of finance. A rate of return needs exactly one inflow and one outflow. We need something that's a lot more general and can deal with multiple flows. So in particular here, we have two inflows. We need a measure that generalizes the rate of return to more than one inflow and one outflow. And the best and most common such measure is the internal rate of return. In the context of bonds, the internal rate of return is called the yield to maturity, YTM. It's really the same thing as the internal rate of return. This is both in wide use and quite useful. You absolutely must understand it. The definition of the internal rate of return, it's a rate of return-like number which sets the net present value equal to 0. So in this particular case, this would be this formula, C0 plus whatever the future cash flow is divided by 1 plus IRR plus whatever the cash flow is the following year divided by 1 plus IRR squared. And of course, if you had more cash flows, there would be more cash flows there. That has to be equal to 0. Now, if you check this, is 9% the correct internal rate of return? Plug it in. Let me know.
Please pause this video now, answer the question on a piece of paper, and then continue.
And the answer is yes, close enough. So plug in the 9%, and well, maybe 8.975% would have been a little bit better. But basically, that is the internal rate of return, just a little bit under 9%. Let's do the next project. You pay $100, and then you get inflows of $5, $10, and $120. If the cost of capital is 12%, is this a zero NPV project?
Please pause this video now, answer the question on a piece of paper, and then continue.
Yes. Let's look at the graph. So if you take the graph, you calculate on the y-axis is the net present value, on the x-axis is the prevailing discount rate, and it just crosses 0 at 12%. So on the left of it, if the interest rate is lower than 12%, the project is a positive NPV project. On the right of it, it turns out to be a negative NPV project. At 12%, it's exactly a zero NPV project. So the internal rate of return generalizes the holding rate of return. Unlike the holding rate of return, it actually works with more than one inflow and one outflow. If there is one inflow and one outflow, then the internal rate of return is the rate of return. So it's a generalization. You can also view the internal rate of return as a characteristic of a project's cash flows. It is a mapping from a set of many cash flows in many periods into one single summary statistic. A statistic is a number that summarizes data the same way that an average summarizes something about many different data points. So it's just like the average or mean, or like a standard deviation, or like a duration, or many different other statistics. It is a statistic. It is sort of a time-weighted average rate of return intrinsic to a set of cash flows. A project with a higher internal rate of return is typically considered more profitable. An IRR is also invariant to scale. So if you multiply every cash flow by the same factor, positive or negative, it still gives you the same internal rate of return. And that's going to play an important role below. In general, there's no closed form solution to calculate the internal rate of return for a project with many, many different cash flows. Only if you have one inflow and one outflow, but then it's the holding rate of return. And that's because, for those math nerds among you, the internal rate of return is a 0 point of a t-order polynomial. Thus, with 3 or more cash flows, typically no algebraic solutions. Fortunately, manual iteration, which is just intelligent trial and error, or graphing it, you get the answer fairly easily. Here's another one. $40 plus first period minus $80 the next period plus $104 third period. Well, you could shift it, would be the same thing. The internal rate of return would be the same. Can you graph the internal rate of return for me? That is, not the internal rate of return. Can you graph the net present value of this project as a function of the rate of return, say from minus 20% to plus 100%?
Please pause this video now, answer the question on a piece of paper, and then continue.
And the answer is here. So it turns out, in this case, there is no discount rate that will make the present value of the project positive. That means you should never take this project. That can happen with the internal rate of return. It's equivalent to saying that you have a project that first costs $10 and then costs another $100, and that's all there is. Of course, it's much easier to see in that particular example than it is to see in the previous example that we had here, because you had some positive and some negatives. In this case, don't take this project at any rate. Let's do another project. So I got a project, outflow of $100, then an inflow of $360, an outflow of $431, and an inflow of $171.60. Confirm or deny. Is 5% the internal rate of return?
Please pause this video now, answer the question on a piece of paper, and then continue.
And the answer is no. You plug in those numbers, out comes a clearly positive number. What about 10%?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, 10% is a good IRR. In fact, I've chosen the numbers so that it works out. The net present value formula comes out to be exactly 0, which means that for this particular project, 10% is the internal rate of return.
Please pause this video now, answer the question on a piece of paper, and then continue.
But what about 20%? Can you try 20% for me? Now we got a problem, because that too is an internal rate of return. Again, the net present value formula comes out to 0. It's a valid internal rate of return. What about this one? is 30% an internal rate of return?
Please pause this video now, answer the question on a piece of paper, and then continue.
Shoot! Yes, a third time. Again, 30% is also an internal rate of return. So one thing you've just learned is the same project can have multiple internal rates of return. Which is the correct one for this project? I don't know. Which answer will Excel give? Beats me. Should we take this project if, say, the cost of capital is 24%? I don't know. So this is how the net present value graph looks like for different rates of return. And as you see, there's actually 1, 2, 3, 4 different valid internal rates of return. And it turns out you should take this project if the rate of return, the discount rate, the applicable one, is less than 10% or between 20 and 30% or above 40%. The zeros separate regions for the cost of capital where you would or would not take the project. But my advice is, when you have projects that look like this, that have multiple inflows and outflows, forget about internal rate of return. Just live with net present value. It's the correct rule and it doesn't give you this inconsistent sign problem. The nice thing about the internal rate of return is that if you have only one cash outflow and everything else is cash inflows, or the opposite, in this case you are guaranteed one unique internal rate of return. So then you don't run into this problem that there's multiple internal rates of returns. Are multiple internal rates of returns obscure? Well, negative positive or positive negative is a very common case for many corporate projects, and it's almost inevitably the case for financial bonds. So if you buy a financial asset, usually you have limited liability, you pay money for it once, and everything else that you will get from it is going to be positive. In this case, you're guaranteed that the internal rate of return is unique. This is also why the yield to maturity is so useful in the context of bonds. There are, however, also projects in corporations that may require big overhauls, maintenance, cleanups. So what you have under those circumstances may be a large upfront payment, then a good number of inflows for a couple of years, then you have to overhaul the plant and you're going to have a couple of negative cash flows again, and then some positive ones again. In this case, my advice is stay away from the internal rate of return. Just use net present value. You must be aware that this can come up, otherwise it can bite you one day unexpectedly. Excel may give you a number that comes out, but it may not be the only number and it may mean something completely different than what you think it means. The internal rate of return as a capital budgeting rule is as follows. Invest if the project internal rate of return is greater than the cost of capital. And this rule leads often, but not always, to the same answer as the net present value rule, and thus to the correct answer. And this is also the reason why the internal rate of return and its use in capital budgeting has survived as a common method for capital budgeting. So it's in use in almost every corporation I know of. Nevertheless, because you cannot improve on correct and perfect, the net present value capital budgeting rule is at least as good as the internal rate of return capital budgeting rule. The biggest advantage to IRR as a capital budgeting rule is that you can compute your project's internal rate of return before you try and ask people whether they will give you money, before you figure out what is your cost of capital. To do the net present value calculation, you have to know the discount rate up front. The biggest disadvantage of the internal rate of return is, in addition to the multiple solutions and no solutions, the absence of scale issue that I've already remarked above. The internal rate of return is useless for comparing mutually exclusive projects. Let me show you why. Compare the following two projects, A and B. Here are the cash flows. Figure out for me, please, what is the internal rate of return? What is the net present value? And as a hint, it's going to be for the internal rate of return between 40 and 60%.
Please pause this video now, answer the question on a piece of paper, and then continue.
Here are the solutions. So the internal rate of return are 47% and 57%. However, the net present value is the same. So even though project B has much higher internal rate of return, it doesn't have higher net present value. If you can take only either A or B, which is better?
Please pause this video now, answer the question on a piece of paper, and then continue.
Well, here you are indifferent. No, B is not the better project. A is just as good as B. If project A gave you just one additional dollar or cent extra, which project becomes better?
Please pause this video now, answer the question on a piece of paper, and then continue.
A, of course. Before they were the same. Now A is better. But B is still going to have the higher internal rate of return. The reason why this is so is scale. A is a bigger project than B. It's harder to see in this particular example, so can you think for me and give me an example where this is much easier to see?
Please pause this video now, answer the question on a piece of paper, and then continue.
No, it's not that hard. Take a 100% internal rate of return on a $1 project. That means your $1 is going to turn into $2. You get an extra $1. On the other hand, a 10% internal rate of return on a $1 million project is going to be $100,000. I would much rather have the second project than the first project. Here's another little problem that we're going to have. So, same project, but now the cost of capital is 8% for 1 year and 10% for 2 years. It's because it's going to be about 12% in the second year, which is what we're going to do in the next chapter. In this case, should you take the project?
Please pause this video now, answer the question on a piece of paper, and then continue.
Who knows with IRR? I don't know. With net present value, the answer is very easy. You just plug in the 8% for the first year and the 10% for the second year, and you can see this is a negative NPV project. Such non-flat term structures, as they are called, are very common, and again, we're going to cover them in the next chapter. So, when is the net present value capital budgeting rule better? Because the internal rate of return is scale insensitive, it creates problems when comparing projects. There may be no IRR, there may be multiple IRRs. The benchmark cost of capital may also be time varying, rendering the capital budgeting rule based on internal rate of return a mystery. When does the internal rate of return have any advantages? Well, the only advantage it really has is that you can calculate it for your project before you have to figure out what is your cost of capital. So you don't have to go out, figure out what is your cost of capital, and every day recalculate it, because every day the opportunity cost of capital changes a little bit. Now, later in this book, repayment uncertainty is going to drive a wedge between promised and expected returns. So I may promise to pay you $100, but I don't always return $100, in which case your expected rate of return is lower. Now, if you're going to use IRR with promised cash flows, all that you get is a promised internal rate of return. Promised cash flows should never be used for capital budgeting purposes. In fact, it's not clear what meaning promises have at all. The really interesting numbers are always expected cash flows and expected internal rate of returns. So for both net present values and internal rate of returns, always use expected cash flows in the numerator. Never use promised cash flows. That's it for this video and for the internal rate of return. We're almost done with our foray into capital budgeting. In the next video, we'll just need to look over a few quote-unquote more applied capital budgeting rules, just in case you encounter them in the real world. I promise that that one will be quick and painless. See you soon. Bis bald.
What does the investment banker say when he can't find the internal rate of return?
What?
What's the internal rate of return?
Really? Is this all you could come up with?
Oh,